Have you ever wondered how a car is able to turn around a corner without skidding off the road? Well, this happens thanks to physics. Although it may seem like something a car is mechanically programmed to do, physics plays a big role in keeping us safe and on the right path. Hi, my name is Bianca, and I'm going to teach you how your car is able to turn a corner without driving off the road. Physics is a very broad topic since many things in our life rely on physics, so we give names to certain movements to understand them more thoroughly. For a car to make a turn, this has to do with the topic called centripetal force. You may be wondering, what is centripetal force? Well, let me tell you about it. Centripetal force is a net force that acts on an object to keep it in motion. Centripetal means center seeking, meaning an object must have a force directed towards the center of a circle to keep the circular path constant. Despite the name force in this topic, centripetal force is not a new force. It is a label for the net force that causes an object to move in a circular motion. These forces are any friction, gravity, normal, or etc. force that pushes or pulls an object towards the center. Now, let's look at a car. When a car goes around a curve, a change in direction happens. For this change to happen, we look at Newton's first law of motion. He states that an object moving at a constant speed in a straight path will continue in that path unless acted on by another force. Considering this law, when the car goes to turn, a force is needed to break the straight path. This force created is friction. Friction is created between the tires and road, which provides the net centripetal force towards the center of a circle, of which the curve is an arc and the car therefore moves in a circular motion. Next, we look at Newton's second law of motion. This law tells us that the acceleration of an object depends on two variables, the net force acting on the object and the mass of the object. When a smart car goes to turn a curve, it is able to do it quickly, unlike an 18-wheeler, which takes some time. This happens because of the mass of the car. However, mass does not affect the centripetal force. If the mass of the car is doubled, to keep the car turning at the same speed, the force must be doubled. Now, let's get into some math. Newton found the equation for centripetal force by combining a few things. Considering moving in a circle, a force is needed towards the center of the circle with the tangential continuous speed. As well, that centripetal force is not a new force, but a net force for friction, gravity, etc. Using Newton's second law, we equalize it to the centripetal acceleration, and wow, we find the amount of force needed to move in a circle. Pretty crazy, huh? Since we learned how friction provides the centripetal force for cars moving in a circular motion, we equal the force of friction to the centripetal force equation, and now we have an overall equation for any car turning a curve. Although we have found that centripetal force is what gives our car the okay to turn, there's one more thing to consider when a car turns in a circular motion. Road conditions. When roads are dry like pavement, a car is able to make a turn easier as the coefficient of friction is between 0.6 to 0.8, allowing for braking time and acceleration. However, when road conditions change and become icy and wet, a minimum coefficient of friction occurs. Changes in speed and direction take much more distance and time, and since there is an insufficient force of friction between the tires and road, the car can lose control very easily and tends to move in a straight path and skid off the road. This is why car accidents are more likely to happen when road conditions are icy or wet. Now, here's a recap of what we talked about in this video. Cars are able to make turns thanks to a little thing called centripetal force. Centripetal force is any force directed towards the center of a circle, but remember, it's not a new force. When a car is turning a corner, it is friction that provides the centripetal force for the car to stay on the road. And finally, road conditions are crucial, as if there is not enough friction present when you turn your car, it will skid off the road. Well, that's it. Now you know how centripetal force allows your car to turn a corner and keep on the road. Thank you for watching.